All right, guys, we did the 8.4a trigonometric ratios and setting up equations in class. So here are the lessons in case you were absent. Angle of perspective. We actually call this the reference angle. So when you hear us say reference angle, this is what we're talking about. This is going to be an angle that is on your triangle. It's either listed with an angle measurement in degrees or this little symbol called theta. It's this little guy right here. It's like a circle or a zero line through it. And the location of this angle is going to change. And so depending on which angle the reference angle is in, your opposite versus your adjacent sides will change as well. So we're going to talk all about this. You will never, ever, ever use your 90-degree angle as a reference angle. Please don't ever use that. You'll be given one of your two acute angles as your reference angle. So what do we mean by this? Well, this first triangle, we look at theta right here. This is our reference angle. I like to put an arc so it makes it really stand out. And so another thing that's going to happen is your hypotenuse is never going to change. Your opposite adjacent sides will change, but your hypotenuse never changes ever in the history of right triangles. Your hypotenuse is always located across from a 90-degree angle. So here's your hypotenuse. When you're standing on your reference angle, if you're going to find yourself going to the opposite side of the triangle, pretend this is a pond or a lake, you're standing over here, you've got to go all the way to the opposite side of that lake or pond. The side CX right here does not touch that reference angle. It's on the complete opposite side. This is where that opposite side comes into play. So this will be your opposite side. Adjacent. We're struggling so bad to remember what this means. This just means next to. So if you share a wall with a sibling or family member, or you're in an apartment and share a wall with another unit, or in the classrooms, we have teachers that are adjacent to us. Okay, me as Miss Collins, Mr. Bloom is adjacent to me. So what happens here is when we look at, we're standing on this angle, this is like my classroom. On the other side of side ZY is going to be Mr. Bloom. So this is going to be your adjacent side. Your adjacent side will always touch the reference angle. It creates that reference angle with the hypotenuse, right? The next triangle, we're switching our reference angle over here to angle X. So when we switch our reference angle, as I said before, one thing that never changes is that hypotenuse. So your hypotenuse stays in the same place. When you switch your reference angle, you're also going to switch your opposite and adjacent sides. What do you mean? Well, now we're standing on the theta over here on angle X. If we go across the lake, across that triangular lake, here's our opposite side, ZY, does not touch that angle, that reference angle. So now our opposite side's over here. And again, we're standing on theta. Okay, here's my classroom. On the other side of the wall, XZ, here's going to be Mr. Bloom's classroom, right next to each other, meaning adjacent. We're going to be using these as H, A, and O when we're using our formulas to write out our equations. We're going to have sine, cosine, and tangent as our three different trigonometric functions. Okay, we can just call them trig functions for short, so we're not having to use a complicated word. Our formulas for sine, we'll have sine of whatever our reference angle is equal to the opposite side over the hypotenuse. Cosine of your reference angle will be adjacent side over hypotenuse, and the tangent of our reference angle will be opposite over adjacent. So we call this, we spell this out, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is going to be opposite over adjacent. We call this SOHCAHTOA. Okay? It's been called SOHCAHTOA for decades and decades. So that's how we can remember our SOHCAHTOA, which sides go where and with which functions. So all we're going to do on this one is we're going to set these up. First, we start off with our reference angle. I'm going to draw that arc on my reference angle. Okay? And what I like to do is first identify hypotenuse. Do I have my hypotenuse? So I go across a 90-degree angle, and I do. So I'm going to write the letter H. The only other side I'm going to label is the other one that I'm given. So over here I see X. Well, standing on our reference angle, do I go to the opposite side of my triangular lake? Or am I right on the other side, right next to the x? I'm not next to the x. I have to swim all the way across the lake to the opposite side, giving me O. So which one of these uses O and H? Right here, sine. So I'm just going to kind of write in that so inside my triangle to remind myself. Following this formula, we're going to write SIN for sine. That theta is going to be replaced with what my reference angle is, that 59 degrees. We need that equal sign. It's not an equation without an equal sign. And here we have opposite, O, which is x, over your h, hypotenuse, which is 16. And there's your equation. On number 2, here's my reference angle. I'm going to go across and check out my hypotenuse. Oh, I don't have a hypotenuse. Do not write the letter H. A little trick, if you don't have your hypotenuse, you automatically have tangent because there's no hypotenuse. So we need to make sure we're labeling O and A correctly. So standing here, I'm going to go swim across that triangular lake or pond to the opposite side, and there's my O. And then I'm going to knock on that wall right there. Hey, guy, you're right next to me. X, you're my adjacent guy. All right? So we realize, again, no hypotenuse. We have O and A as tangent, so we'll have our TOA. So we'll fill in this formula. We have our tangent, TAN, of my reference angle here, 64. Set it equal to, forget that equal sign. We have opposite, O, 23, over adjacent, A of x. There we go. Number 3, we don't have a number, but remember, whenever we talked about your reference angle, it is either going to be a measurement in degrees or it will be that theta symbol. So here we have the theta symbol, so here's our reference angle. Do we have the hypotenuse? Go across the 90-degree angle. We do, H. So we know we're not using tangent. And then we need to stand on that reference angle and say, do I need to go all the way across, swim across the triangle, or am I just knocking on the door right here and right next to it? We are right next to it. That 2 is right next to that angle, so we have next to adjacent. A and H is using cosine. So here we'll have our cosine of, now we don't have a measurement, so you have a couple options. You can use your theta, or if you don't like theta, I would say if you have a problem with theta, literally you have a problem on a paper with theta, but you also have a problem with theta, you don't like using that symbol, you can always replace it with the letter X. You'll see X in the angles also. So either one of these will work. We're going to have our, forgot to write the K for SOHCAHTOA. Okay. So we're going to have our A adjacent 2 over our H, hypotenuse of 5. And it'll look the same regardless of whether you use theta or X as your angle. I want you, this is what I did in my classes, I want you to pause and I want you to try 4, 5, and 6. Now, if you got the Google Doc, you are missing some pieces. Okay, on 4, you need to fill in the X and the 49, 5, the X and the 53, and I think 6 is okay. So fill those in. I really want you to pause it and try it on your own and then resume and let's see how we did. Congratulations, you have finished all on your own. Good job. I'm going to go pretty quickly through this one, okay? Reference angle, okay? I have across, got my hypotenuse, and then the X is right next door to the 49, giving me my adjacent. So I'm using K and SOHCAHTOA, the cosine. So we fill in cosine of my reference angle 49 is equal to adjacent A, X, over hypotenuse H, 9. I'm just going to stick with the same color. I know you guys like my colors, but number 5, reference angle. Do I have my hypotenuse? Yes, right in H. Now, I find myself having to swim all the way across that triangular lake, all the way across the opposite side of the lake to get to that 13. So I have opposite. O and H is going to go with sine for my SO and SOHCAHTOA. Set it up. Your sine of your reference angle was 53. And then we're going to have opposite O, 13, over hypotenuse H, X. Lastly, Over here, we're missing an angle again, measurement, but we have theta. This is still going to be our reference angle. I do not have hypotenuse. Oh, I don't have hypotenuse. I know I'm using TOA, tangents, because it doesn't use hypotenuse. Even though the numbers are the same, you still need to make sure you're labeling. So we're getting practice. I'm going to swim all the way across the opposite side, and there's my O. And I'm going to go right next door on the other side of that side, and that'll be my adjacent. So we end up with the tangent of theta, or x, is equal to, well, we have the same number, 8 over 8. Just like with proportions, you can simplify this. If you plug this in with 8 over 8, you're going to get the same answer as if you plug it in with 1 over 1, or just simply 1. So any of those will be acceptable. Make sure that on your exit ticket, on number 7, it does say on canvas. On number 7, you need to make sure that you put an X on that hypotenuse. Okay, and then we want to make sure that we set up all 12 of these equations. Set them up at the top of the rectangle, please, because the next step is going to be, once we learn to solve it, we're going to use the rest of the room to solve for these and submit on Canvas.